Hi everybody, this is Professor Wondu Chang of Pugyong National University. Today I want to talk about bioelectric signals and electrooculogram. Okay, these are the contents of today. Let me skip it and let's start from the signal. So bioelectric signal is the signal, a type of signal. So you need to know about the signal at first to understand the bioelectric signals. Okay, so what's the signal? So look at the person, look at this referee. So he's holding his hands, his arms, and then we know he's showing a signal. He's sending a signal. So there's some problem, so he's showing a signal, right? But how do we know that he's showing a signal? Because his actions are similar. His postures are different to the normal posture, normal and natural posture, because there was a change. So if there is some change, then we can know there is a signal. So think about a person, two person, man and woman, boy and girl, and thinking that the boy like that girl and sending a kind of signal that he likes her. Okay, but if his signal is just like the normal behavior of him, then how does she can recognize that he is sending the signal to her? So to recognize and to understand that he is sending the signal to her, then he needs to be something different to the normal, right? So that's the signal. So according to the definition of the dictionary, then a signal is a detectable physical quantity or impulse by which messages or information can be transmitted. So that's the difficult version of what I explained. And we are going to talk about the electric signals. So electric signals are the signals in electric form. You see here some lines, a graph. So this is a graph of electric cardiogram. So ECG, the signal from our hearts. Okay, so this is a kind of a sort of electric signals. And the one common sense you may know is the magnetic signals occurs simultaneously with electric signals. Okay, let's move to the bioelectric signals now. Our body is full of electric charges, and these charges changes when we move our body. Our body continuously moves. Our hearts moves, our muscles moves, our brains are working and sending the signals each other. And our eyes also are continuously moving. So we can record one by one. So the signal caused by our hearts is called ECG, and the signal caused by our eyes are named as EOG, Electrooculogram, which we are going to study more. And EEG is the brain signal, and EMG is the muscle signal, and PPG is our pulse signal. Okay, so I told you that there are lots of electric charges in our bodies, and these charges, electric charges, plus and minuses, are moving here and there according to our movement. Then how can we record this movement of electric charges, these changes? How can you record? So we need this kind of device. This is a multimeter to check the voltage difference, electric potentials difference between two spots. So basically you can think about a battery. So this battery is very familiar to us, a plus and minus. And simply we can think there's actually inside of this battery is pretty complicated, But simple, we can imagine that in minus parts are full of minus charges, and then the first part is a lack of electric charges, minus electric ions. Okay, then how can you measure the electric potentials, electric charge differences? So we need to put two probe on each side. One is on minus side and the other is on plus side. Okay, then we can check the difference, the electric charges difference between two spots, and it's not that difficult. So it is pretty easy, just checking the impedance between these two spots. But if we try to measure exact amount of electrodes, electric charges at a spot, that is very difficult. So this is one easy way to record and to measure the electric charge differences. Okay, so we need two spots, right? Two probe. We put one at minus and one at plus, and then we check how is the difference between two spots. So that's what we are doing. Even when we are checking the electric battery, a dry battery, a voltage, and also when we are checking the voltage or electric potential, we say, between two spots in our body. You got it? So when you check the electric potential or electric voltage between two parts of the battery, plus and minus, then usually it does not change, right? Usually it does not change. So if it's a small battery of 1.5 voltage, then it is going to be 1.5 or 1.46, 1.54, something like that. So it does not change. If it does not change, then we do not call it as a signal. But if it changes, it could be changed very fast. So then we can say this is a change and this is the signal. That's what happens in our body. Okay, then we can use this kind of signal to control computers. This guy, the right upside of image, that he's now not watching video game, he's playing video game, and the person in the bottom is playing video games with his arms and fingers. So upper part, he's playing game with his eyes. So we record the signal of eyes, and then he may control with his character using his movement of his eyes. And the person in the bottom is playing guitar games with his finger movements, and we cannot see the device, but it's hidden here, and it records the EMG, his muscle movements, and then he can play the games with that device. So that's what we can do using this kind of signals. And then let me talk about the EOG or detail. So actually EOG is a signal caused by eyeball movements. So you can see the eyeball inside of the eyeball structure, and you see the cornea and the retina. And cornea is so this is the eyeball, and then you can imagine this works like a battery, a dried battery. So here cornea part is relatively plus charge, and then retina is relatively minus charge. So when we are moving our eyes, turning here and there, and then the battery is turning around. You got it? So there is a look at my finger, and this imagine that this is a battery and inside the eyeball, and when I see here and there, and plus charge with my finger, near my finger, is going to be increased, and plus charge far from my finger is going to be decreased. So that's what happens when we are moving our eyes. So I told you, do you remember that I told you that we need two probe to measure some electric potential between two spots? Yes. So when we are recording our EOG, we often put the electrodes, the two probes, to the rightmost of the eyes and the leftmost of the eyes. So then the electric potential changes and maybe increased when the eyeball, our cornea, comes nearer to the plus probe. Okay, and when it comes further from the plus probe, then it's going to be the lower. So signal occurs according to our eye movements. So this is the real EOG. So the previous one, this one, is like some kind of a, how can I say, sample and ideal movements, ideal changes of our eye movements, EOG, and this is the real. You see some noises, but basically it changes just what I said. And there are two components here, because when we are recording EOG, we used to put 4 electrodes, left and right, and then up and down, so 4. And we can check vertical components and horizontal components. So if horizontal components go plus, then that means I saw the right side. And if you go upward, it's higher with vertical components, then which means I look at upward. Okay, so this is pretty easy to understand. And there are many kinds of eye movements. There's a fixation, saccades, miniature movements, smooth pursuit, and versions. So I do not want to explain everything, but there are some important things. The first one is saccades. Saccades is a very fast eye movement. So you see there is very big changes here. Big changes. Very sudden changes. Dynamically, it goes up and down, down and up. And these are called saccades. So actually our eyes are really fast. When I look at the forward, and if there's something happens right side, I just look at the right side, and then my eyes are moving, and this is really fast. And in the signals you can see there are very, very fast changes happens here. Okay, and the fixation is when I fix up my gaze into up spot. Okay, now I look at this character EOG, then my eyes will not open. My eyes will not move. But I say this is a movement fixation. Why? Because even when I see at only a single spot, my eyes are going to move continuously. Our eyes. It's not only my eyes, but also your eyes are continuously moving. So slightly. That's the movement of fixation. And when we are moving, when we look at an object moving slowly in front of our eyes, then our eyes will follow it, right? Then that is smooth pursuit. So that's the signal a little bit different, and a bit moving very slowly and gradually, not like these sudden movements. So these kind of different signals happens in our eyes. So occurs in our eyes according to our eye movements. Okay, and so let me explain what we can do using this kind of EOG. And you can there are many papers, research papers about EOG, utilizing EOG, and this is a paper that he developed a wheelchair, electric wheelchair, which can be moved by eye movements. So when I look at moving my eyes upward, very high, very high position, then it moves up forward, and then if I look at very lower, then it decreases the speed. Okay, so maybe you are a bit curious, fuzzy, that because we used to look at here and there, and when we are moving, then what happens then? So our wheelchairs are going this way, that way, and zigzags movements, some problem. But we can put some threshold, because when we are moving, when we are looking at somewhere and some places in our natural life, we do not move our eyeball a lot, and usually we move our eyes in narrow angles, very narrow angles. So for example, if something happens in my right side, and then something happens and there big sound on my right side, then I will look right, not only moving out, not just moving up my eyes, but also moving together with my head, right? I look at it like this. So not just we do not usually moving our eyes alone. So that's why we can use this kind of devices. Okay, and also we can play some games. And I can't sure whether you are familiar with this kind of games. It's called the DDR, Dance Dance Revolution. It's a very long time ago game. And then maybe we can use VR games. And so this is about 8 years ago paper, and it's, this developer used the eye blinks signal and then upward eye movements for this game, to play this game. So left, right, blink, jump maybe, and then we can play some game. So this kind of applications we can use. This is a human-computer interface. This kind of techniques are called the human-computer interaction. So because our movements, our body movements are related to computer or some devices. Okay, and this is my research. It's pretty old now. It's also 8 years ago. But this is eye writing, and this is natural eye movements. I used utilize the eye movements to write characters directly. So there are many techniques tracking our eye movements using the vision cameras. But here we do not use the vision cameras, but we only use the EOGs, electrooculogram signals. So this kind of a device or this kind of HCI could be utilized for patients who cannot speak or who cannot write, and he may not able to use their bodies to communicate. Then only his available action is the eye movements. So it often happened for ALS patients. So I think this is one technology which can be utilized for those patients. And okay, so here in this research I recorded some signals from ALS patients, and then we confirm that we can utilize this technique for those patients. Okay, and also we can utilize this EOG for cerebral response or eye movement analysis during sleep. This is pretty useful because the major technique to record our eye movements is eye tracker using the camera, but when we are sleeping, it's very difficult to tracking our eye movement. So this kind of techniques utilizing EOG is pretty good to record, very useful to record the eye movements during sleep. And also we can use this for action estimation as well. Okay, then let me explain about EOG based HCI system in general. So at first we need to measure the signal, and then we can process the signal using filter and some kind of pre-processing techniques, and then we can extract some features and we can apply pattern recognition algorithms, and then we can apply it to HCI using the communication. Maybe we can write or type keyboards, or we can control something. Okay, let's just check one by one. Okay, this is a photo which I took. This is my student, and then so to record EOG we put 4 electrodes on his face, so left, right, up and down over his eyes, and we can record this signal, EOG signal, using stationary device just like this, or also we can use the portable devices as well. Also, this is the electrodes here in the photo are the wet electrodes, but also we can use dry electrodes as well, and we can put the electrodes put the electrodes on the face just like this. This is very typical, so left, right, up and down, but there are many other tries. So just with the 2 electrodes just like this, B and C, and also 4 electrodes not up and down but the corners, some diagonal places, A, B, C, D, and then also there are some unique position to record the EOG on nose. So you can see this glasses, and then you will see nose part here. They are actually electrodes, dry electrodes. So this is pretty convenient to record the EOG. And also there are tries to record the EOG from inside of our eyes. So this is also possible. And to record the signals clearly, so we do many things. At the previous, so to find, for example, we try to find the best position of electrodes, where we try to use the best amplifier, and so different types of electrodes. But anyway, the measured signal has some kind of noises, and then we need to remove the noise to make it accurate software to understand that. So there are some problems and some noises like this crosstalk and DC drift. Crosstalk is a signal mixture between the horizontal and vertical components, and DC drift is continuously changing of signal in very low frequency. So sometimes the signal is just coming up and up and up, going up and up and up, and sometimes it goes down. So that is called DC drift. And also there are high frequency noises, and also there are eye blinks. So some people think that eye blinks is a part of EOG, but actually precisely saying eye blink signal is different to the EOG signal, because basically EOG signal is caused by eye movements. That is called the EOG, but eye blink signal is caused by our eyelids, and then eyelids and our cornea. And when our eyelid touches cornea, then the electric potential rises very sharply. That is called the eye blink signal. Okay. To remove this kind of noises, we use lots of filter and then wavelet filtering and frequency-based analysis, or maybe template matching. And there are many kinds of tries. And these are very traditional ways. Sorry, there's Koreans, so I tried to remove all the Koreans and try to write in English, but I forgot this slide. And then after that, our job is to extract the features. So actually, in these days, lots of researchers use the low signals directly, because deep learning techniques are getting improved a lot. So it can understand very wisely from the raw signals, patterns from the raw signals. But still, when there are not enough signals and deep learning techniques are not working, then feature extraction is also available. Okay, and the next job is trying to recognize the patterns. So maybe we can recognize, we can classify how the movement is. Maybe a person is drawing A or B or C, D, E, F. So we need to classify which signal, which character he is drawing, or maybe we need to recognize whether this is eye blink or eye movements. So there are many techniques and many models. Traditional models are ANN and dynamic time mapping, dynamic position mapping, support vector machine, or human hidden Markov model, and there are so many things, many other things. But in these days, as you know, the most researchers use deep learning techniques. So because this is very promising in these days. Okay, so I explained what we can do, and then what we need to do to build a system using EOG. Okay, so that was my presentation, and actually this presentation is to make you understand and to give you basic knowledge about our biosignals, and especially about the electrooculograms. So I wish you may understand more about the electrooculogram, and because this is a very short lecture, so you may not this may not cover all the recent researches. So if you are interested in, then please search the recent papers. Also, I published a number of papers about the EOG, so you can also search my name to find more information. Thank you very much.